All right, this is video 18 for College Algebra. Today we're going to be talking about rationals and basic algebraic rules with them. So first of all, we always need to remember that we should factor first. So when we're looking at a rational, whatever you do, factor first, and then it'll make your life a little bit easier. And then we also need to define the domain. We need to identify those values that would make the denominator equal to 0. That's where we have those asymptotes, and we can't divide by 0. So those become numbers in our domain that do not exist. So first of all, let's start off, again, factor. So first I'm going to look for that GCF. And I've got a GCF actually of x on both the top and the bottom of my fraction. All right, and then from there, I can actually factor. So I like to use my multiply add pair. So multiplies to negative 24, adds to negative 5. That would be negative 8 and positive 3. I still have my x. And then in the denominator, I've still got my x. And I think, okay, what multiplies to negative 72 and adds to 1? Well, that would be 9 and negative 8. So from here, I can now simplify. I can now reduce. If there's something on the top and the bottom, you can cancel those off. So here I've got an x. I can cancel those off. And I've got an x minus 8. So after simplifying, my answer becomes x plus 3 over x plus 9. Now we also have to define our domain. That's what makes our denominator equal to 0. But we can't do it just from our answer. We have to do it from our beginning. So I like to use my fully factored form before I cancel anything out. And so to do so, to find those values that x can't equal, we put each one of our factors equal to 0. So x plus 0, or x equals 0, x minus 8 equals 0, and x plus 9 equal to 0. So clearly x equals 0, x equals 8, and x equals negative 9. So the values that x cannot equal, that should be positive 8. There we go. And negative 9. So all of these parts are included in our answer. All right, so we've got our fraction, and then we also have our domain restrictions, or those values that x cannot be. All right, so when we multiply, again, we're going to be doing the same thing, is looking at, first we have to factor. So if I look at the numerator here, again, this would be, after you factor, we're trying to multiply to 30. So let's do our big X. So we're multiplying to 30, adding to 11. And we start with a 2x on the top and on both sides. So that would be 5 and 6. So this would be 2x plus 5, and we reduce this to just x plus 3. In my denominator, I don't have to do as much. I just take out a GCF of 4x, and I'm left with x plus 3. All right, over here, again, I can take out a GCF of 8, and I got x minus 3. And in the bottom, we factor. And we have 2x plus 5. I forgot an x there. And x minus 5. So now we can look at things to cancel. X plus 3's, and we can cancel things if something's on the top and the bottom. So my 2x plus 5's These two can't cancel, but my 4 and my 8, I can cancel there. I can cancel my 4 out altogether, and my 8 will become a 2. So then we write everything that's left over. So the things that are left over in the numerator would be 2 and an x minus 3. My denominator, I have my x and x minus 5. Now again, we have to write those domain restrictions, everything that would make each factor equal to 0. So we can put each of those equal to 0 and solve. So here we'd have x equals 0. We would have x equals negative 3, x equals negative 5 halves, and x equals 5. So those are the values x can't equal. 0, negative 3, negative 5 halves, and 5. So all of this is our answer. Now when we divide, here we are going to multiply by the reciprocal. And so that means we keep the first fraction the same, we flip our division to multiplication, and then we flip-flop that second fraction. So let's rewrite this. 2x squared plus 8x over x squared minus 1. We're going to change to multiplication and flip-flop our second fraction. So here's my new problem. Now, after I factor, this is what we are left with. Remember, we've got this difference of squares. And then we're just factoring, multiplying to negative 4, adding to 3. That'd be positive 4 and negative 1. And here's our second fraction. All right, so now we look at things that we can cancel off. I've got a x minus 1 and an x minus 1. I have 3 x plus 4s. Now I can only cancel them off if there's one on the top and the bottom. So I could cancel off this one and this one, but this guy's left over. All right. My x plus 1s, those are both on the bottom, so I can't do anything there. And my 2x stays. So I'm going to have 2x times x plus 4 and x plus 1 squared. All right, and then we write what x cannot equal. And hopefully you're getting the hang of this. So what plus 1 would equal 0? That'd be negative 1. What minus 1 would be 0? 1. And here this would be negative 4. Now we also have to look back from our original equation because at one point x squared plus 3x minus 4 is in our denominator as well. But for us, it's just the same values, so I don't have to rewrite those. So this is my final answer. And our last one, we are adding and subtracting. Here our example, we are adding. Again, factor first. Here we're just factoring our denominators. And here, with adding and subtracting, we have to get common denominators. And that's why sometimes adding and subtracting can be a little more difficult. All right, so I've got an x minus 1, an x plus 1, and an x minus 2. Those are all the different factors that I have. I need both of my factors to have all 3 of these factors. So I'll underline our different factors. Now I'm not underlining this -1 because I've already got one over here. All right, so all fractions need to have all of these factors. So let's get common denominators. So this first fraction is missing an x minus 2. So I'm going to add that to my top and bottom. So I've got an x plus 1, x minus 1. I'm going to put an x minus 2. Now if I add it to the bottom, I have to also put it to the top. All right, so that one's done. Our next fraction, I'm going to go ahead and put this in the same order as we have here. So we've got to put an x plus 1, and I need an x plus 1 at the top. All right, so now they both have the exact same factors in the bottom. When that happens, we're going to combine our numerator. So we're going to combine like terms. I like to go ahead and simplify these and multiply them out. So this actually is x squared plus x minus 6, and this is 2x plus 2. And that way it's a little easier to add. So my new fraction is x squared plus 3x minus 4. Let's go ahead and we will write these in the same order. All right, so I'm not quite done yet because I can factor and I could still reduce. So this has a lot of steps. So this numerator can be reduced or simplified to x minus 1 and x plus 4. And then I can actually reduce. These x minus 1s I can simplify. And I am left with x plus 4 over x plus 1 times x minus 2. And our domain restrictions here would just be 2, -1, and 1. All right, so this is adding, subtracting, multiplying, and dividing rationals.